Welcome back to another session of construction planning. We are in the we have started learning about the network methods, in which we have started about what is network, what is activity, what is event, types of activity, types of event, rules for drawing the network. Then we have seen the numericals. Based on drawing the network, there were three category of numericals. After that, we have started the actual network method, that was critical path method. So in a separate lecture, we have discovered entire theoretical concept of critical path method. We also learned that in critical path method, we need to find the critical path, and for that we need to understand the parameter of float. There were four types of float: total float, free float, independent float, and interfering float. We have learned all of that. Then we have seen a numerical in which on a network we perform forward backward and we find three kinds of answer. First, total duration of project. Second, critical path of the network. And third, table of floats. So that was about CPM method, and those activities who are having total float 0 were considered as critical activities. Those activities who are having total float 0 were considered as critical activity. So today in this session we are going to learn, yes, we are going to start PERT method. Our second network method, our second project planning method is PERT, PERT method, and then we are going to see numericals based on PERT method. So let us start with the conceptual background or the theoretical fundamentals of PERT method. So PERT stands for Program Evaluation Review Technique. PERT stands for Program Evaluation Review Technique. It is a project management technique which is used for planning, monitoring and controlling of a project. Now students, we have learned that CPM method is activity oriented method. So PERT is event oriented method. Focus on that. We are learning the PERT method as well as we are learning the difference between CPM and PERT. That CPM stands for critical path method, PERT stands for program evaluation review technique. Second, CPM is activity oriented method while the PERT is event oriented method. Then CPM method is applicable for the repetitive kind of projects. Such as railway, bridge or industrial or factory building. While PERT method is useful for non-repetitive kind of projects such as research project or space project. CPM method works on deterministic approach. CPM method works on deterministic approach. Now what do you mean by deterministic approach? Students, deterministic approach, that means you are aware that what time will be taken by the activity, that in X duration activity will be completed. But PERT method works on probabilistic approach, and that probabilistic approach uses 3-time estimate. So now as we just learned that works on probabilistic approach and 3-time estimate, let us see what are the three estimates. So here, while working with the PERT method, we need to focus on 3-time estimates. The first is optimistic time, denoted by TO, most likely time, denoted by TM, and pessimistic time, denoted by TP. Optimistic, most likely, and pessimistic. Starting with the optimistic time. So the optimistic time is the shortest possible time in which the activity can be completed in the ideal condition. Here, students, while approaching the planning of activity, optimistic stands for positively, that what if everything goes right? If my material arrives on time, if my labor arrives on time, if my equipment works properly, so in what time, in as early as possible, in what time, as early as possible, I can complete the activity. So that is the case of optimistic time, right? Now, let us move forward with most likely time. So the most likely time is the time in which the activity completed under normal conditions. So in this most likely scenario, something goes right, some things goes right and some things goes wrong. 50-50 scenario. So that is your most likely time. That in most, what is the most likely time to complete this activity? That time falls between optimistic and pessimistic. So that is your most likely time. Next is pessimistic time. Next is pessimistic time. So the maximum time required to complete an activity is known as pessimistic time. Pessimistic time is the maximum time which is required to complete the activity. Pessimistic time is the best guess of time. Yes, students, focus on the words that pessimistic time is the best guess of time. Why? Because the estimation by pessimistic time is considered with the aspect of all the abnormal conditions such as earthquake, fire hazards or floods. So pessimistic is the worst scenario, that late by late, in what time I can complete my activity. Late by late, in what time I can complete the activity. That is your pessimistic time. So PERT method works on probabilistic approach, and probabilistic approach having three time estimate: optimistic, most likely and pessimistic. Now again, optimistic that means if everything goes right, in what time I can complete the activity. The minimum time, the shortest time. Most likely, that means what time it will take to complete the activity under normal conditions. And pessimistic, what if everything goes late, then as late as possible, in what time I can complete the activity. That is under abnormal conditions. So optimistic, pessimistic and most likely. But now students, in CPM method, what do? We were doing that activity and duration was given, then we perform forward backward. But here in PERT method, three estimates are given. For an example, if we talk about excavation, so in CPM method it was given that excavation take 10 days. But in PERT method, excavation either can complete in 5 days, either can be completed in 7 days, and either pessimistically that been completed late by late in 10 days. So how to represent that? Ultimately students, this is a point of common sense. Ultimately, an activity only requires a single time. But here, PERT is considering 3 times. It is not possible that that excavation will take 3, 5 and 7. Activity will only get 1 time. So we need to convert that 3 time into a single time. What we need to do? We need to convert this 3 times into a single time. So that is the formula for that is, so expected time TE equals to TO plus 4TM plus TP divided by 6. TO plus 4TM plus TP divided by 6. That is the formula for expected time. Along with that, there are 2 more formulas. The one is standard deviation. The formula for standard deviation is TP minus TO divided by 6. And the formula for the variance is TP minus TO divided by 6, the whole square. The whole square. TP minus TO divided by 6, the whole square. So these are the 3 formulas which will be very helpful in the calculation of the numerical of PERT method. Now students, what kind of questions asked in PERT method? So in PERT method, there could be 3 questions asked. First, total duration of the project. Second, critical path of the project. And third, probability of the completing the project in another duration. But in CPM method, to find the critical activity or to find the critical path, we need to focus on concept of float, or we need to find total float. So what to do to find critical path in PERT method? So students, let me tell you that what is float in CPM method, that is slack in PERT method. What is float in CPM method, that is slack in PERT method. Let us understand the slack. So as you know that PERT method is event oriented method. So slack can be defined as difference between latest event time and earliest event time. The difference between latest event time and earliest event time can be defined as slack. So slack equals to TL minus TE. TL minus TE. So critical path is the path which is connected by the activities having slack 0 or minimum slack. Those activities who are having slack 0 or minimum can be considered as critical activities in PERT method. So I hope we are clear about total duration. We have to follow the forward backward fundamental. For critical path, we need to find the slack. Now the third question which I was mentioning about, that is probability. And the probability, to understand the concept, let us see a numerical first. So let us see the numerical. So first question of the PERT method is that for the network shown in below or the network shown in figure, determine the critical path of the activity. So here is the first question of the PERT method, that for the network shown in below or the figure, find out the critical path of the network and determine the probability of completing the project in scheduled time. Determine the probability of completing the project in scheduled time. TS, first TS is given as 34.67 days and second TS is given as TS equals to 36 days. Also calculate the latest occurrence time and the earliest occurrence time. The 3 times estimate is represented on the each activity and the value of probability corresponding the Z value is represented in the table. So the probability concept which we need to define, which we need to find, is from this table. So the question is that a network is given. On that network, all 3 time estimates are given. We need to find the critical path and we need to find the probability for 2 cases. On first case, what if I want to complete the project on 34.67 days, and what if I don't want to complete the project in 36 days. So let us see the network given in figure. So here is the network given in the question. This is the entire network with the 3 time estimate is given to us in the question. So as you can see, there are event number 1 to 10 and activities are represented by 1, 2, 1, 3, 2, 5, so and so. So now as you can see on the above the arrow, there are 3 time estimate is given. Above the arrow, there is 3 time estimate given in the network. So as you can see for 1, 2, it is 357. So now from that 357, who is TO, TM and TP? Who is TO, TM and TP? So students, when there are no clarifications are given, first is TO, center one is TM and the last one is TP. So 3 is TO, center 5 is TM and the last 7 is TP. Alright? So that is how the entire network is given. Generally, in the numerical of CPM, what we do is we start from 0. We start our forward analysis and backward analysis at point 0. Now, but here in PERT method, there are 3 time estimate. So we cannot have forward path analysis and backward path analysis. First, we need to convert from this 3-time estimate to single estimate, and for that we know the formula TO plus 4TM plus TP divided by 6. So let us prepare the table. Alright, so here is the table having activity data, TO, TM, TP, TE, standard deviation and variance column. Now activity, TO, TM and TP are given in the network. So I have translated all the data from network to table. Now to perform forward and backward, our first step is to find the TE. So formula for TE is TO plus 4TM plus TP divided by 6. And we know all three formulas. So we can find, applying the formula, that TM multiplied by 4 plus TO plus TP divided by 6. So we can find the column of TE. So let us do that. So as you can see over here, this is the entire column of TE. So this is the single time estimate which will be required to complete the activity. Now this duration, we need to represent that into the network. So let us represent that into network. But before we move forward to the network, as you can see, the sum of the values of TE are in decimal, such as 14.17, 5.83. So do not round it off. In PERT method, the duration values can be in decimal because we are working on probabilistic approach. So now let us put this TE value into network. So as you can see over here, the single estimate, the expected time TE, I have represented that into network below the arrow. So below the arrow, I have represented the single time estimate. Alright. So now I got the single time estimate. So I can start the forward path analysis and backward path analysis. And that process of forward path analysis and backward path analysis is the same as CPM method. So we will start from point 0. Let us start. So as you can see, I have started from point 0. So now my focus is to reach from event number 1 to 10. From event number 1 to 10. So I am starting from 0. So 1 to 2. So for 1 to 2, timing is 5. So 0 plus 5, 5. Now let us talk about 3. So for 1 to 3, timing is 2. So 0 plus 2, 2. Now 1 is completed, 2 is completed, 3 is completed. Let us talk about 4. So for 4, there is only one way. 3 to 4, 2, and the timing is 12.17. So 2 plus 12.17, that is 14.17. Now for event number 5, there are two ways, 2 to 5 and 3 to 5. So if I go from 2 to 5, 5 plus 8.33, 5 plus 8.33, so that is 13.33. And if I go from 4 to 5, 14.17 plus 0, that is 14.17. So I have got two answers, 13.33, 14.17. So I'll consider maximum point. So 14.17. So now 5 is completed. Let us move to the 6. For reaching the event number 6, there is only one option, 4 to 6. So 14.17 plus 9, that is 23.17. Now 6 is completed. Let us go to 7. So to reach 7, there is only one way, 4 to 7. So 14.17 plus 5.83, so that is 20. So we have reached up to 20 and event number 7. Now let us talk about event number 8. So event number 8, there is only one way, that is 5 to 8. So for 5, that was 14.17 and duration for 5 to 7 was 7. So 21.17. Now let us talk about event number 9. To reach event number 9, there are two ways, 6 to 9, 8 to 9. So if I go from 6 to 9, 23 plus 17 plus 2, that is 25.17. But if I go from 8 to 9, I'll get 21.17 plus 5.83, 27. So 25 and 27. What is greater? 27. So I'll consider 27. So that is my event number 9. And the last is event number 10. So there are two ways, 7 to 10, 9 to 10. So if I go from 7 to 10, for 7 it was 20 and the duration was 14.67. So 20 plus 14.67, that is 34.67. And from 9 to 10, 27 plus 4, so that was 31. So maximum was 34.67. So we'll consider 34.67. So that is my forward path analysis. Student, I am repeating it again. I have discussed this into the last lecture CPM method, that if your network is consisting of a dummy activity, you need to consider it forward analysis and backward analysis. We have to show the path of forward and backward while doing the, we need to consider dummy while doing the forward and backward analysis. So our final point on the forward path is 34.67. Now let us do the backward calculation. To do the backward calculation, let us start with 34.67 at the event number 10. Now I am going from event number 10 to 9. So 34.67 minus 4. So that is 30.67. Now up to event number 9, that is 30.67. Now 9 to 8. So to go to 9 to 8, there is only one way. 30.67 minus 5.83, that is 24.84. Now we have reached up to event number 8. Let us talk about event number 7. So 34.67 minus 14.17, that is 20. So we have reached up to event number 7. Now for event number 6. So from event number 6, there is only one arrow coming out. So reverse will be 9 to 6. So 24.84 minus, so 30.67. So 30.67 minus 2, that is 28.67. So that is for event number 6. Now let us talk about event number 5. So for event number 5, there is only one way, 8 to 5. So for 8, it was 28.84 minus 7. So that is 17.84. Now let us talk about event number 4. So for event number 4, we can have 5 to 4 and we can have 6 to 4 and we can have 7 to 4. There are three options, 7 to 4, 6 to 4, 5 to 4. So if I go from 5 to 4, 17.84 minus 0, 17.84. If I go from 7 to 4, 20 minus 5.83, 14.17. And if I go from 6 to 4, 28.67 minus 9. So that will be nearly around 19. So the minimum is 14.61. We are doing backward calculation. We need to consider the minimum value. So 14.67. Now let us do it for event number 3. So we have only one path, 4 to 3. So 14.16 minus 12.17. 14.17 minus 2, 12.17. So remaining 2. Now let us talk for event number 2. So for event number 2, 17.84 minus 5.83. Pardon me, 8.83. So 17.84 minus 8.83, that is 9.51. And now for event number 1, 2 minus 2, 0. And 9.51 minus 5, that is 4 point something. So 4 point something and 0, minimum is 0. So we'll come back to 0. So that is my forward and backward analysis. That is my forward and backward analysis. And by performing forward and backward analysis, I can have the total duration of the project, that is 34.67 days. The total project duration is 34.67 days. I hope we are clear up to this point. Now students, we need to find the critical path of the network. We need to find the critical path of the network. To find the critical path, we need to understand the slack. And the slack is TL minus TE. So what is TL and TE in our network? TL and TE in our network is square and triangle values. That is a TL and TE for particular event. What you write in triangle and square, that are the TE and TL values. Square is TE, earliest event time, and the triangle values are TL. So the slack was saying that whose slack is 0 will be critical. Whose slack is 0 will be critical. So we can say that event number 1, 3, 4, 7, 10 are critical. So the connecting part 1, 3, 3, 4, 4, 7, 7, 10 will be critical. So let us highlight that. So here is the highlighting of the critical path. Students, I am repeating again how I have decided the critical path. TL minus TE should be 0. So at event number 1, 0 minus 0. Event number 3, 2 minus 2. Event number 4, 14.17. Event number 7, pardon me, 2020. And event number 10, 34.67. So we can say that the total duration is 34.67 days and critical path is 1, 3, 4, 7, 10. So that are our two answers have been completed. Total duration and critical path. Now, what about the probability of schedule time? The first schedule time was given 34.67 days and second schedule time was given as 36 days. So students, here the question is trying to say that your project is being completed in 34.67. Now calculate the probability to complete the project in 34.67 or 36 days with the use of that Z table. And to understand that, we need to understand the formula. Let us see. So here is the formula to calculate the probability, that is Z factor or Z formula, TS minus TE upon under root of sigma square. TS is schedule time. In how much time you want to complete, that is given in question. That is known as schedule time. In our this question, there are two schedule times. TE, total expected time, that is our final answer. In our sum, the TE is 34.67 days. Now the denominator is under root sigma square. That is the most important. Student, focus, under root sigma square. So variance is a sigma square and he is at that root of that. So the denominator is square root of sum of all the variances of critical activities. Again, the denominator is square root of sum of variances of critical activities. So now let us find the standard deviation and the variance of for the given network. Alright, so here is the standard deviation and the variance. You know the formula for standard deviation, TP minus TO divided by 6, and variance sigma square, that is TP minus TO upon 6 the whole square. So we can get the values of SD and V. SD is sigma, V is sigma square. So now to find the probability, square root of sum of variances of critical activity. So what are the critical activity? 1, 3, 3, 4, 4, 7, 7, 10. Highlight it. Let us highlight the variances of that activity. So here are the variances of critical activities, that 1, 3.110, 3, 4, 2.25, 4, 7, 0.649, 7, 10, 4. So let us calculate the square root of sum of critical activities. So the square root of sum of variances of critical activity will be under root 7.054, that is 2.65. Now let us calculate the probability case by case. So let us consider the first scheduled time, that is 34.67 days. Let us see. So here is our case 1 where the scheduled time TS is given to us 34.67. We know the formula that Z equals to TS minus TE upon under root sigma square. So TS 34.67, TE 34.67 divided by 2.65. So 0 divided by 2.65. So that is 0. So that is 0. Now let us recall the table of probability and Z given in question. So here is the table of probability and Z. For value of Z0, probability is 0.50. So in percentage, that is 50%. So for first case, to complete the project in 34.67 days, the probability is 50%. I hope we are clear about this point. Now let us come back to the second case. So for second case, TS is given is 36 days. TE was 34.67. So Z equals to TS minus TE upon under root sigma square. So we'll get the value of Z as 0.5018 or 0.5014. That is nearly equal to 0.50. So again, the table of Z, we can interpolate that this is nearly equal to 0.5. So the probability will be 72%. So that is how we can find the probability. So this is it. That was all about in today's session. We have learned about the theoretical concept of PERT. That PERT is event oriented method, probabilistic approach, 3-time estimate, TO, TM, TP, formula of TE, standard variation, variance, what to find in probability, how to do forward backward. When there is a dummy in forward back, then when there is dummy in network, we have to calculate it in the while doing the forward backward. So in case of any query or doubt, you can always contact me in my mail or my number. Thank you.